Oh, shit.
Ready to rock and roll here. All right, now, radiation. Can you shut that door there, Professor? Thank you. Radiation. Radiation is light, correct?
Yes.
Radiation is light. What are the longest light waves called? More or less, más or menos. What are they called? Starts with an R. They're thinking. Yes, they're radiation, but what kind of light waves? Well, we're going back to middle school, maybe last year in chemistry. They're called, the longest wavelengths are called, starts with an R. Listen to the radio waves. Very good. Radio waves are the longest waves. Cool? Are we all right with that? Yeah. They're like several meters. They're like 2-3 meters long. They're very long. Okay, very big. Okay, if you could see them, they would be obvious. 2 meters long, 3 meters long, from peak to peak. Correct? Yes. Okay. As a side note, this is a little bit difficult of a subject to teach because we're not, this unit comes before the unit on light. So I am going to teach electromagnetic radiation as it related to your last course, chemistry. Understood? So we're not necessarily going to talk about a lot of the mechanics of light. Not a lot of them. Okay. But you have radio waves are long. What are a little shorter than radio waves? What are they called? Microwaves. The man said microwaves. Absolutely. Why are microwaves a little weird? They're a little strange. What is it about microwaves that make them probably one of the most well-known waves? When I was in high school, you never really talked about microwaves. But why are microwaves, which are a little shorter than radio waves, why are they so unique? You can heat up food. Water, the structure, there's something about the structure of water that loves microwave energy. It absorbs. The water in the food will absorb microwave energy and it will get hot. Matter of fact, when microwave ovens were first out and they were at some fast food restaurants, they had very poor insulation and people were injured by the leakage of microwaves because the body is mainly made of water. So if microwaves are heating the water in your body, what's one of the largest organs in your body?
Skin.
Skin, brain, what else? Heart. Your liver. And your liver is right below your rib cage, right exactly where a microwave oven might be. Oh. Yeah. Oh. Yeah. Mickey says, oh my God, the light went off. Boom. Yeah. So they're dangerous. They're dangerous. They actually are dangerous. And there's all kinds of urban legends about microwave ovens, etc. There is no difference in heating your food in microwaves as opposed to regular conventional means. It's the same. Now the container might degrade, so you have to use a proper container. But microwaves are microwaves. Microwaves are energy. They don't change the food. They don't change the food. Microwaves are energy, just like heat, which you would use to heat your food, would be energy. All right, now what are a little shorter than microwaves as we're going down? We're going from long, over here long, radio waves to the shortest wave. So what is it?
Infrared.
Infrared, not infrared, infra, I-N-F-R-A, red. One word, infrared. Those have shorter wavelengths than the microwaves. What's another word for infrared radiation? Starts with an H. Anybody? Heat. Yeah, heat. Heat is infrared radiation. Okay? Now, what is next?
Visible light.
visible light is even shorter than infrared. And how does it go? This is long wavelengths. We're getting short. What visible light ray is the longest visible light ray? What is it?
Ultraviolet.
No.
Red.
Oh, red.
How do you know? Infrared, red. Roy G. Biv. Radio waves, microwaves, infrared, Roy G. Biv. Right?
Yeah.
Biv, violet. So what's even shorter than violet?
X-ray.
Ultraviolet. Violet, ultraviolet. Not violet X-rays. Violet, ultraviolet. That makes sense?
Yes.
Now, what's bad about ultraviolet rays?
They're
Give you
too small.
cancer.
Yeah, they can mutate your genetic material, essentially, and cause cancer. What's one of the deadliest forms of cancer?
Skin.
Malignant melanoma, skin cancer. Malignant melanoma, it's a specific type of skin cancer. Tanning is very toxic for you. You might better go and play in traffic.
Wait, like a tanning bed or the sun?
Tanning bed, or any kind of sun. It's bad for you. You'll get cancer. And you may not pay now, but 20, 30 years from now, you may pay. You can't lay in the sun, especially someone like me who's very fair. I can't do it. I've had melanomas removed, and it's scary. Tanning beds are toxic. It's interesting to me, in New York City, the mayor is trying to ban very large sodas, like more than 16 ounces. Like,
Yeah, I heard that.
you heard that? 32 ounces, right?
Yeah.
And because it causes health problems if you have too much sugar, diabetes, heart conditions, etc., right? Yet they have tanning beds, which are far worse than a sugary soda, especially if you're active. I mean, yeah, ban the sodas. I have no problem with that. But why are you letting the tanning beds stay in operation?
Makes no sense.
Didn't they try to ban them in New Jersey?
I don't really know, but ultraviolet. The lesson is ultraviolet radiation is something you want to avoid. You know, you want to use
Spray tan.
sunblock
Spray tan.
with what? What do you call the stuff in sunblock? SPF, right? Is that right?
Yes.
SPF 1 million you should use.
I use 8.
If we can find
You
it.
use 8. I would use
50.
something stronger.
I use
Use 30.
I use 300.
You use 300?
I can't
Yeah,
get dark.
yeah, exactly.
It's detrimental.
Understood.
I'll
So
look
you
at
want to
it.
use something that has a high SPF, right? The sun is unavoidable. And the sun has good things. It helps produce
Vitamin D.
vitamin D. It helps some good brain chemistry. You feel better in the sun. That's why people like to, hang out at the beach. There's one reason. Light is good. Light is helpful. But too much of it, not good. Okay? Now, what's even shorter than ultraviolet?
X-rays.
X-rays. What's shorter than X-rays?
Gamma rays.
Gamma rays. So it goes radio, micro, infrared, Roy G. Biv, ultraviolet,
X-rays.
X-rays, gamma rays. Now, if the spectrum went from New York City radio waves to LA, how thick would the visible light spectrum be? 3 or 4 miles? Short? It'd be the thickness of a coin. Ish. That's a little bit of an exaggeration, but the point is, the visible light, it's so important to humans, so important. But yet it is a very, very small, almost insignificant part of the electromagnetic radiation spectrum. What I want to teach you now is I want to talk about energy transfer using radiation. There's 3 types of energy transfer. There's conduction, which is easy. You touch the object. Convection, we'll talk about in the next video. But radiation, look at this. Doesn't the sun heat the earth?
Yes.
All right. The sun is 93 million miles away from the earth, right? And the distance between is almost about 0 Kelvin. There's almost no heat, -273 Celsius. So how does the sun heat the earth? It doesn't heat the earth because it's hot, otherwise space would be hot, right? Doesn't. How many people have heard said, the sun is really hot today? Is that correct?
No.
No. What would you say instead?
Radiation is heavy.
No, the sun is very bright today. Because the sun heats the earth by using light. Let me explain. Visible light, this is very simple explanation. You can take entire graduate courses on this. This is basic stuff, okay? Understand this, yes? But it's the beginning. Dorothy started at the beginning of the yellow brick road. We shall start at the beginning. Understood? Excellent. Visible light comes from the sun, short wavelength-ish, okay? Easy?
Easy.
Sun, visible, I can see it, visible light, short wavelengths. Yes? Okay. Comes through the atmosphere, unimpeded. Comes through the atmosphere, unimpeded. Yes? Okay. It is absorbed by something, a rock, something. That just this represents the earth, that box. That's the earth, correct? It's going to absorb that energy. And then how do you know it absorbed the energy? How do you know? Because the object gets hot. And what kind of radiation is hot? Infrared, yeah, heat, right? So it gives off infrared. What has a larger wavelength, a longer wavelength? Infrared or visible?
Infrared.
Infrared has a longer wavelength. So short wavelength comes in, long wavelength can't get out. It's trapped. Reabsorbed. It's like Twitter. You retweet. Is that right?
Retweet it.
Retweet. Okay.
Retweet.
I know a lot about Twitter, don't I?
Yeah.
Okay. So the heat builds up. Give me an example of everyday life. The middle of July, New Jersey, 95 degrees out. You have a car. You have a black interior, black steering wheel,
Ooh.
no tinted windows,
On fire.
and you want it, and the car's been sitting in a parking lot from 11 a.m. to 2 p.m.
Oh, it's on fire.
You go into the car. What's it like? Hot. How do you know it's hot? Before you even open the door, how do you know it's hot?
The radiation comes out.
You can feel it. How about if you touch the window? What would it feel like?
Hot.
So some of the heat's getting out, isn't it? Isn't some heat getting out? Is it all blocked? No. A lot of it's blocked, but it's not all blocked, is it? How do you know it's not all blocked?
Because it's so hot.
You can feel it. You can feel it from the outside. So some of the heat is getting out, right? So you can see it. Yes? Okay. Well, why does that happen? How do you know the sun can get into the car? How do you know the sun can get into the car? How do you know the light can get into the car? How do you know? By not opening the door, what observation can you make?
Heat waves.
Heat waves? No. How do I know sunlight can get into the car by standing outside the car?
Windows.
What about windows?
They're trans.
I can see it. No, don't explain the physics. Give me an observation. You can see in the car, right?
Yeah.
Well, how can you see in the car? There's light waves. There's light waves in there. They come in the sun, they bounce, and they go to your eye, right? So you know visible light can get into the car because you can see the inside, right?
Mm-hmm.
Right? So the short waves come into the car, long waves can't get out of the car. What is this called? What is this called? It's an effect. What effect is it? Elizabeth.
Greenhouse effect.
It's called the greenhouse effect. 3 energy transfers. Conduction, which is easy. Put your hand on a hot frying pan. Does it feel hot?
Yeah.
Yeah. Really hot, correct?
Yeah.
Really hot.
Yeah.
Don't do it. Don't do it.
You just told us to.
No, don't. Don't try this at home, okay? Convection, we're going to talk about next. Radiation. So radiation is the transfer of energy from the sun by light. Short wavelengths from the sun converted to longer wavelengths by an object absorbing that light. Are we clear? The beginning. The beginning. Understood? Excellent. Hey, have a great day. And you know what? Wear sunblock, always.